Hi there, today we are going to apply the Pythagorean theorem. Before we get started, let's review the theorem. The theorem helps us find sides of right triangles. The sides that form the right angle are called the legs. We use the variables a and b to represent the legs. The side across from the 90-degree angle is called the hypotenuse. We use the variable c to represent the hypotenuse. The Pythagorean theorem is a squared plus b squared equals c squared. Or in other words, the leg squared plus leg squared equals the hypotenuse squared. Let's go through some example problems. Our first example problem asks us to calculate the length of the hypotenuse. Since we have a right triangle here, 28 is one of the legs, 21 is the other legs, so we're going to label those with our a and b values. We're going to start with a squared plus b squared equals c squared. Now what I would like you to do is to actually plug in the a and b values and find the length of the hypotenuse. So push pause, calculate the length of the hypotenuse, and then push play again. Okay, let's go ahead and plug in 28 for A, 21 for B, 28 squared is 784, 21 squared is 441. When we add those together, we get 1,225. And then remember, the last step is to take the square root of each side, and our c value is 35. Or our hypotenuse is 35 centimeters long. Let's move on. To the nearest tenth, what is the value of x in the triangle below? What I want you to do is push pause, find the value of x, and then push play again and we'll go over the solution. To the nearest tenth, what is the value of x in the triangle below? Since we have a right triangle, we're going to use Pythagorean theorem. Let's label our a and b values. Since 12.9 and 17.2 form the right angle, those are going to be at the legs. When we plug in our values, we get 12.9 squared plus 17.2 squared equals our hypotenuse squared. Let's go ahead and simplify. When we add those together, we get 462.25. And lastly, we need to take the square root of each side. So c equals 21.5. Remember, they want to the nearest tenth, so we're only going out to one decimal spot. So the hypotenuse is 21.5 inches long. Let's try another one. The two legs of a right triangle have lengths of 6 centimeters and 7 centimeters. Calculate the length of the hypotenuse to the nearest hundredth of a centimeter. Since there isn't a diagram with this one, what I would suggest is that you draw and label a triangle before starting it. Let's go ahead and push pause, try to find the length of the hypotenuse, and then push resume again. All right, let's go ahead and draw our right triangle and label it. This side is going to be 7 centimeters, and this side is going to be 6 centimeters long. Those are going to be our A and B values. So let's start with A squared plus B squared equals C squared. Plug in 6 for A, plug in 7 for B, and simplify. When we add those together, we get 85. And then remember, lastly, we need to take the square root of each side, and our C value equals, we have to go out to the nearest hundredth, so it's going to equal, we have 0.219. But since it's the nearest hundredth, remember we want to round that up to about 9.22 centimeters long for the length of our hypotenuse. All right, let's go on to the last problem for today. A rectangular table is 7 feet long and 3 feet wide. How long is the diagonal of the table? Let's go ahead and start with the rectangle. It's 7 feet long and 3 feet wide. We need to figure out the diagonal. Go ahead, push pause, see if you can figure out the length of that diagonal. Push play again and we'll go over the problem. Okay, as you can see, a right triangle is formed when we draw that diagonal in there. So therefore we can use Pythagorean theorem. In this case, the legs are going to be 7 and 3 feet. So let's go ahead and plug those values in. Simplify. 7 squared is 49. 3 squared is 9. When we add those together, we get 58. Lastly, we need to take the square root of each side. And our hypotenuse is about 7.6 feet long. All right, that wraps up things for today. Have a good one, and remember, live the dream.